In this video, we're going to look at an example of completing the square. And this is a very interesting expression because it doesn't look quadratic or where the highest powers are 2. So we're going to complete the square in this expression x plus the square root of x plus something, and we're going to sort of find out what this something is and turn it into a perfect square. Now the first thing to note is that a perfect square is really in this form, isn't it? So in fact, if it's a perfect square, it can be factorized into a binomial. So a perfect square sort of binomial, a plus b all squared. The thing is that we need to obviously work out what the a is and what the b is. Now let's go back to our original expression, x plus the square root of x. I know that with perfect square expansion, so a plus b all squared, when you take the first term of the binomial and you square it, you should get x. So in this case, x plus square root of x plus, now the b, when you square it, it's actually b squared, isn't it? Now the first term is x. So we know that this first term, when you factorize that into a perfect square, sort of a binomial, the a is in fact the square root of the first term, x. So in fact it'll be root x in the brackets there, plus b all squared. So this problem now has become, let's find the value of b. So when I square it and get b squared, I've actually completed the square on the sort of the expanded version of this perfect square instead of the factorized version. So we're working with the factorized version of the perfect square here. Now from the right hand side, let's expand this. Okay, so x plus root x plus b squared is equal to, now let's expand square root of x plus b. Okay, so all squared. So square root of x all squared, hopefully we know how to expand a perfect square binomial. So that's going to be x plus twice the product of the terms inside the brackets. So that's going to be 2b root x plus b squared. Now what we're going to do is equate kind of the like terms. Okay, so this x here, I'll just get a different color pen that makes it a little bit more apparent what I'm about to do. This x here is equivalent to this x here. This b squared here is equivalent to this b squared here. These two expressions are in fact equivalent to each other. In fact, by rights, I probably should use an equivalence symbol. It doesn't really matter at this point. It's just more to sort of understand what we're doing here. And 2b root x, well, it's equivalent to this term here, root x. So let's just focus on this middle term here. Root x is equivalent to 2b root x. Okay, so therefore whatever's the coefficient of square root of x here on the left hand side should be equal to 2b. So in other words, 2b equals 1, therefore b in fact equals half. So let's go back to our original expansion then. Okay, so our original perfect square, so there's the expansion there and there's the factorized version there. We've got b equals half. Okay, so hence, okay, root x plus half. Okay, since we found the value of b, in fact we could square that, you get 1/4. You can put a quarter in there and we've answered the question. Let's just for the exercise, let's expand this. Square root of x all squared is just x plus twice the product of the inner terms. So that's 2 times half times root x, or 2 times half is 1, then you've got root x. So that's fine. So that's all good. So that the first two terms are the same as our original expression there. Now the question mark. Okay, so this question mark here is going to be half all squared plus 1/4. And we have just completed the square on the expression x plus the square root of x. Thanks for watching.